I'll compare TheilSenRegressor and ordinary least squares, OLS, regression. Think of them as two different ways to draw the best fitting line through a set of data points. OLS is like a straight ruler. It tries to get as close as possible to every point and is easily thrown off by unusual points, outliers. TheilSenRegressor is more flexible. It's less worried about being close to every single point and more focused on finding a line that represents the overall trend, making it more resistant to outliers. This is a multiple-choice question testing your understanding of TheilSenRegressor. You'll need to select all the true statements about its properties. This sets the scene. We are using a specific tool, TheilSenRegressor from the Sklearn library, to handle a dataset which may contain some unusual, extreme data points, outliers. I need to choose which statements accurately describe how TheilSenRegressor works. This statement explores the robustness of TheilSenRegressor to outliers. Is it better than OLS at ignoring unusual data points? I'm exploring the computational aspects here. Does TheilSenRegressor take more computing power than OLS? Here, I'm focusing on how you use TheilSenRegressor. Do I need to input the intercept manually or is it calculated automatically? This asks about how the algorithm uses the data. Does TheilSenRegressor use each data point directly in its calculations, or does it use them in a different way? I'll explain TheilSenRegression. It's a method to find the best fitting line through data points, but it's smart about handling outliers, data points that are unusually far from the rest. Unlike ordinary least squares, OLS, which can be heavily swayed by outliers, TheilSen focuses on the median slope between all pairs of data points. This makes it much more robust. Think of it like this. Imagine you are finding the middle height of a group of people. A few unusually tall or short people won't significantly affect the median height, whereas the average height, like OLS, would be influenced more by them. Now, let's talk about OLS, ordinary least squares, regression. This is a classic way to fit a line to data. It directly calculates the line that minimizes the sum of the squared distances between the data points and the line. However, this method is very sensitive to outliers. Those outliers can pull the line in their direction, resulting in a line that doesn't represent the overall trend of the data well. In contrast to TheilSen, OLS is like finding the average. A few extreme values heavily influence the result. This question asks us to identify correct statements about TheilSen regression compared to ordinary least squares, OLS, regression. We need to understand how each method handles outliers and the computational demands of each. It's a test of our knowledge of robust regression techniques. This statement is false. TheilSen regression in scikit-learn automatically estimates both the slope and the y-intercept. You don't need to provide them. I find this convenient. This is also false. While TheilSen considers all data point pairs to calculate slopes, it ultimately uses the median of these slopes to fit the line. It's not a simple weighted average of all points. This is true. TheilSen uses the median of slopes, making it more resistant to the distorting effects of outliers compared to OLS, which is sensitive to individual data point influence. Yep, true. Again, calculating the median of all pairwise slopes is significantly more computationally intensive than the matrix operations used in OLS. In comparing TheilSen regression and ordinary least squares, OLS, regression, I'll focus on how they handle outliers and their computational speed. Think of it like this. OLS is a super fast but fragile race car, while TheilSen is a sturdy, slower truck. The truck can handle rough terrain, outliers that would wreck the race car. I'm asking you to identify the true statements from several choices regarding the TheilSenRegressor. This statement is true. TheilSen uses the median of slopes between data points. The median is much less affected by outliers than the average used in OLS, making TheilSen more robust. This is also true. To compute the median of all possible slopes between data points, requires significantly more calculations than the direct matrix calculations used by OLS. This is false. The TheilSenRegressor in Sklearn automatically estimates both the slope and the intercept. You don't need to provide it. This is false. While it considers all pairs of data points to calculate slopes, it uses the median of those slopes for the final fit. It doesn't directly weigh each data point individually. Statement A is true because TheilSen's median-based approach makes it robust to outliers. Statement B is true because calculating pairwise slopes and finding their median is more computationally intensive than OLS. I'm asking you to identify which statements correctly describe the TheilSenRegressor, a robust regression method in Sklearn. It's all about understanding how it handles outliers and its computational demands compared to standard OLS regression. This will test your knowledge of its core properties. This statement is true. The TheilSenRegressor uses the median of slopes between data point pairs for its estimation. Unlike ordinary least squares, OLS, which is heavily influenced by individual data points, especially outliers, the median approach makes the TheilSen method much more resilient. Think of it like this: the median is less affected by extreme values than the average, mean, used in OLS. This is also true. Calculating all those pairwise slopes and then finding the median is computationally much more intensive than the matrix operations used in OLS. OLS is a straightforward calculation, while TheilSen involves many more computations. This statement is false. The TheilSenRegressor in Sklearn automatically estimates the intercept. You don't need to provide it. And this is false. While all data points contribute to the calculation of the pairwise slopes, the final model is determined by the median of these slopes. It doesn't directly weight each data point individually. Think of it as a summary statistic rather than a direct use of all points. I'm comparing TheilSen regression and ordinary least squares, OLS, regression. I'll focus on how they handle outliers and their computational demands. Think of it like choosing the right tool for the job. I find that TheilSen is slower. Why? TheilSen calculates the median slope from all possible pairs of data points. That's a lot of calculations. OLS, on the other hand, uses direct matrix operations. It's much faster. It's like comparing sorting a deck of cards by hand versus using a machine. I see that TheilSen is more robust. It uses the median of slopes, making it resilient to extreme values, outliers. Outliers don't heavily influence the median like they do the average, which is what OLS uses. Imagine finding the middle height of a group of people. One extremely tall person won't affect the median height as much as it would the average height. I've discovered this is false. You don't need to manually input the intercept. TheilSen automatically estimates it. Think of it as a helpful assistant that does the calculations for you. I found that this statement is also false. While it considers all points for calculating pairwise slopes, the final model is based on the median of those slopes, not a direct weighting of each point individually. It's more of a summary statistic rather than direct use. It's like summarizing a long story by just stating the main point, not reciting every single detail. I'm comparing two regression methods, TheilSen and ordinary least squares, OLS. I'll examine how they handle outliers and their computational speed. This is a multiple-choice question testing your understanding of TheilSen regression. The question asks you to identify the true statements about TheilSen regression from Sklearn, a popular Python machine learning library. TheilSen is slower than OLS because it calculates the median of slopes between all data point pairs, which is more computationally intensive than OLS's direct matrix calculations. No, you don't need to explicitly provide the intercept value. TheilSen automatically estimates it. No, it uses all pairs of points to calculate slopes, then uses the median of those slopes. It doesn't use each point's value directly in a weighted average. TheilSen regression is a robust method that finds the median slope from all possible pairs of data points. It's great at ignoring outliers. Ordinary least squares, OLS, regression is a common method, but it is very sensitive to outliers. Outliers can strongly influence the fit. TheilSen is robust, meaning it isn't easily affected by outliers in your data. OLS is very sensitive, Even a few outliers can significantly alter the results. TheilSen is more computationally expensive because of all those slope calculations. OLS is computationally efficient because it uses simple matrix operations. This is true. Because TheilSen uses the median slope, individual outliers have less of an impact than in OLS.